Okay, continuing, this is from the part 1, how to isolate an atom from a compound. Continuing just to look at some additional examples. I did actually pull an example from ohm number 7, just again to show you that variation and how the problem's going to be worded, so you know when you have to do that extra step of that mole ratio to pull out the atom, and when you're just going to solve it regularly like we did in the earlier tutorials. So if you look at this one, it says consider a 6.33 gram sample of C2H2. How many molecules are in this sample? Now you'll see in this question, there is no mention of pulling out a specific atom. It does not ask how many atoms of carbon specifically are in the sample, or how many atoms of hydrogen are in this sample. It just straight says, how many molecules is this? So that tells me that I am not going to need the mole ratio to pull out a specific atom because I'm not asked about a specific atom. So this is going to be solved just the same way that we had solved these mole conversion questions earlier. So I'm starting with grams of C2H2. The problem wants me to go to molecules. If I refer to my mole conversion chart, I'm given grams. I want to go to molecules. They are separated by 1, so I know this will be a 2-step conversion. My first step will be grams to moles, and my second step will be moles to molecules. So grams of C2H2 is on the top, so I'm going to put that on the bottom to get it to cancel, and we know my first step is to moles. Mole gets the number 1. If you add up the molar mass of C2H2, we said that that was 26.036. Okay, now I'm in moles. The question asks for molecules, so I have one more step. Since moles is on top, I'll put moles on the bottom to get rid of that. And then I can go directly from moles to molecules. Where moles is, that's where the number 1 goes. Where molecules is, that's where the 6.022 times 10 to the 23rd is going to go. Okay, so just solving this one as normal, rounding it to 3 sig figs, you should get 1.46 times 10 to the 23rd molecules of C2H6. So again, I just wanted to throw that in there just as a reminder. You will not always need the mole ratio. Really pay attention to the question. See if it is asking you to isolate out one particular atom in that compound. If it is not, then you're just gonna solve it like normal, just using your mole conversion chart. All right, so we're gonna do a final one. This is exercise 30. Again, under that same section in your textbook, unit 2, that we're under right now. So how to formula mass in the mole concept. So this one has, tells us that we have a tube of toothpaste, and we have a amount of toothpaste that is 0.76 grams, which might be equal to what you were to put on your toothbrush. Toothpaste, the form of fluoride in your toothpaste, it comes in sodium monofluorophosphate. So as you can see out of this whole thing, the only part that's really, well, in our question, the fluoride piece of it is only one small part of the actual ingredient in the toothpaste. So just because you have 0.76 grams of the sodium monofluorophosphate on your toothbrush does not mean you're getting 0.76 grams of fluoride. So that's what this question's asking you for. It wants to know, okay, if you have this amount of this compound, what mass of the fluorine atoms, and we're going to actually take it in milligrams, was present. So since I'm given an amount of a whole compound, but asked just to isolate out one of those atoms, I am going to have to use that mole ratio step. So we're going to go ahead and start with what we're given, which is 0.76 grams of the sodium monofluorophosphate. This is just one indication to you about how naming is so much beyond what we actually do in this class. I know many of you might seem overwhelmed, but there are literally hundreds of ways that we name compounds and exceptions. So you're seeing an example of one of those right now. We won't talk about this one, but it's probably nothing like you've seen so far. All right, so since I want to isolate out fluorine, I know the only way to do that is by using the mole ratio. So my first step is going to have to be to take this amount in grams and put it into moles. And we know from our conversion step that this can be used this can be done in one step. I'm just going to call it SM for sodium monofluorophosphate, just for the step right here because I'm going to be running out of room. Grams to moles. You wouldn't want to do that, but again, due to my vision of what you're seeing, I need to kind of reduce my space. Moles always gets the number one when we do our conversions. Outside of the mole ratio, grams, if you add up the mass of this whole compound right here, you should get 143.95. So now I'm in moles. And this is now where, since I'm in moles, I can go ahead and pull out that atom in question. So the atom I'm looking at is fluorine. So again, this step here, this mole ratio step, is going to be the only step that's going to allow me to do that. And I can say for every one sodium monofluorophosphate molecule, I am going to have just one fluorine. These units canceled. Okay, now the question doesn't ask for how many moles of fluorine, it asks for how many milligrams of fluorine. So now I have to pick up and continue. Once I've pulled out the fluorine, then I can go back to my mole conversion chart to get the rest of the way there. So moles to grams, this can be done in one step using 1 for moles and then the mass on the periodic table for my grams. Moles is on top, so we'll put moles of fluorine on the bottom. We'll convert to grams to fluorine. For every 1 mole of fluorine, if you look on the periodic table, our mass is 19 grams. And then we want to go to milligrams, so we're going to have one final step. Grams is on top, grams is on bottom, grams to milligram conversion. 1 gram is equal to 1,000 milligrams. That was back from Unit 1. Okay, now we can go ahead and if you go through and solve that, you're gonna get like 100.3 milligrams. We can only have 2 sig figs based on the start of this problem. So the easiest way to do that, this is a really weird number to put into 2 sig figs because if you just made it 100, that would just have 1. If you put 100 with a decimal point, that would have 3. This doesn't happen super often, but whenever it does, I normally recommend to just put it into scientific notation, and then that's an easy way to get those 2 sig figs that we need, times 10 to the second. So in that amount of toothpaste, you would have about 100 milligrams of the fluorine. Part B of this question asks, how many fluorine atoms were present? Okay, so again, I'm still asking to isolate out the fluorine, but instead of wanting to know how many milligrams of fluorine there was, I want to know how many atoms of fluorine there was. So again, starting with that same sample amount, we're going to walk through the same way. We need to take my grams to moles in order to be able to do the mole ratio to pull out that fluorine that's in question. Okay, mole of Na2PO, 3F. Now I can do, since I'm in moles, I can do a mole ratio for every 1 sodium monofluorophosphate molecule, there's just 1 fluorine. Okay, so again, this is my special step. The only step that's gonna allow me to pull out an atom is doing that mole to mole step. Once I've pulled out the atom, then I can continue and do the problems just like we were before. So now I've transferred over to fluorine. Mole of fluorine is on top. Mole of fluorine will go on the bottom in the next question. Moles to atoms can be done in one step because they're right next to each other. Wherever the mole is, that's where we're gonna put the 1. And then atoms gets the 6.022 times 10 to the 23rd. Okay, if you multiply across the top, divide by the bottom, round your answer to 2 sig figs. If you use 0.76 toothpaste sample that has 0.76 grams of the sodium monofluorophosphate, that means that you're going to have in that sample about 3.2 times 10 to the 21st atoms of fluorine or fluoride. Okay, and there's that.